Hello, my name is Joshua Mack. This is my associate Sebastian Hernandez.
Hello there.
And today we're going to be presenting our roller coaster, the Alien Invasion, to you for your consideration to add it to your parks.
Thank you.
So the kinetic energy is highest from the top all the way to this point because this is where the speed is going to be building up and being faster, and the kinetic energy will only change when the speed if the speed changes. Now, some people might think because this is the tallest point on the roller coaster that this is where the potential energy will be the highest. But potential energy is due to its location. So if it were there, it'd be already in motion, so it'd be kinetic energy. But while the marble stops for a little bit of time that it does here, this is where the potential energy is the highest because it's stopped right here, and that's the highest point on the roller coaster. The lowest point of potential energy would be here because it's stopped and it's the lowest point on the roller coaster. Same thing with the kinetic energy. It's not moving, so it's stopped. So there's no kinetic energy or potential energy.
So right here, going down, this is going to be the positive acceleration because of the slope, how it is, right? So then right here, it's negative acceleration because the slope is going up. So that when the slope goes up, it's going to decelerate, and it's negative deceleration. Same thing here, it's going to gain a little bit of speed and a little bit of acceleration, right? So then here, it's going to have the same, and right here, it's going to start like slowing down and getting negative acceleration because it's traveling at the same speed. Here, the slope going down this way, it's going to add acceleration, positive acceleration, and then here it's going at constant speed, and the friction and the gravity is going to start slowing down the ball, and by the time it gets there, it's going to be stopped.
Newton's first law states that an object at rest will stay at rest, and an object in motion will stay at motion. So when the ball is rolling down, if there was no friction or gravity, but there is, the ball would roll forever and ever and ever until the ball finally slows down eventually, and if it doesn't, this outside force, which is the stick, hits the ball and makes sure it doesn't go past outside of the ride.
As Newton's second law states, force equals mass times acceleration. That is happening throughout the whole entire ride, as you can see here, because every time the force acting upon it will be the gravity, and it's just going to keep going like this. The acceleration, it's going to be how fast it's going down, so it's happening. The mass of the ball is also causing it to change throughout the whole entire thing.
Newton's third law states that for every action there's an equal and opposite reaction. The first action that occurs is us dropping the marble onto the roller coaster. Once the gravity is the reaction on the marble, and it makes it go through and spin and go all the way through. The final action is this marble hitting against the stick. The reaction is that the energy from the stick may bounce the marble back a tiny bit.
For the two forces acting upon the marble are gravity and friction.